Hey everyone, so given question is from the chapter States of Matter, but it's also mixed with fluid mechanics and thermodynamics. So, but majorly we can say that it's from States of Matter. Okay, it's a PYQ of JEE Advanced 2022, paper 1. So the question goes like this. An ideal gas of density rho is equal to 0.2 kg per meter cube enters a chimney of height h at a rate of alpha is equals to 0.0 kg per second from its lower end and escapes through the upper end shown in the figure. The cross-sectional area of the lower end is this, okay, and the upper end is this. The pressure and the temperature of the gas at the lower end is 600 pascals and 300 Kelvin, while its temperature at the upper end is 150 Kelvin. The chimney is heat insulated so that the gas undergoes adiabatic expansion. G is equal to 10 meters per second square, and the ratio specific heats of the gas is this. Now, gamma, we know gamma is equals to 1 by F by 2 plus 1, U is equals to F by 2 plus 1, so that implies degree of freedom is equals to 2. I like to put R over. R won't come. Yes. This just implies that CV is equals to 2R. We're going to need this thing future. Okay. Now first let's calculate the pressure at the top part. So pressure, it's an adiabatic process. P to the power gamma is constant, which implies that 2 to the power gamma into P to the power 1 minus gamma is constant. We put the values, okay. So 300 square and 600 minus 1 is equal to 150 square. Can we call this P1? This is P1, 600 pascal. P2 inverse. This implies that P2 is equals to 600 by 4, that is 150 pascals. Okay, so the first option is wrong. Now the second option asks for the velocity. Okay, so velocity at the lower end we can calculate from alpha. See, density is mass by volume, alpha is kg per second, so alpha volume is adx by dt, right? adx, then we can write this in this way: volume is this, mass is this, differentiating both sides, so you get alpha a v1 as your density. From here you get v1 as 0.8 by 0.1 to 0.2, which comes out to be 40 meters per second. The first part is correct. Also, PV is equals to nRT, which implies PM by RT is gamma. So PM by RT is rho, which is density. That implies density is equal to P by T. So rho 1 by rho 2. We can use that, right? Rho 2 by rho 1, rho 2 by rho. Rho 2 by what is rho 1? Rho 1 is 0.2. So you write 0.2 over here. Pressure 150 by time temperature 150, and then temperature is 600, 300 by 600. Now, rho 2 comes out to be 0.1. So what density of the gas at the upper end is 0.1. It's not 0.05 kg per meter cube. So option 4 is wrong, right? After this we use equation of continuity. Alright, according to which rho 1 a1 v1 is equals to rho 2 a2 v2. Rho 2 is 0.1, a2 is 0.4, v2 is, we don't know, v1 is 40, a1 is 0.1, and rho 1 is 0.2. So this is equals to V2 is 20 meters per second, which implies that option B is correct. Okay. Now for the height of the chimney, let's use the energy approach. Okay. So the work done is equal to delta K plus delta U plus internal energy change. Okay. Work done is P1A1 into dx plus P2A2 dx to x1. Right, that is equals to half mv2 square minus half mv1 square plus change in internal energy, the mgh plus energy, which is 2 by 2 or f by 2 is cv, right? So yeah, 2 by 2 r into t2 minus t1. So this would be, this is just 1 r. Okay, now this is basically P2V2 minus P1V1 by ideal gas equation, and P1 A1 dx1 is basically V1 and P2 dx is basically its delta, change in entire thing. Okay, that is P2 into V2. Okay, that V1 and V2 is volume over here. Okay, right, otherwise let's do one thing, we'll differentiate by dt on both the sides. Okay, P1 A1 delta x1 by delta t plus P2 A2 delta x2 by delta t, this is time, is equals to half m V2 delta t minus half m by delta t V1 square plus mgh delta t is equals to, again we can write this as the same thing, right? P1 A1 delta x1 by delta t, so P2, right, minus P1 A1 delta x1 by delta t, okay, it's equal to plus. We'll take P2 A2 delta x2 by delta 2 in this side, and we know what delta 1 by delta t is. It is your velocity v1. So basically P1 A1 v1 two times now. Also this would be minus 2 times of P2 A2 v2 is equals to half alpha v2 square minus half alpha v1 square plus alpha gh. Alright, so we know all the values except the height. So on calculation the height comes out to be 360 meters. So even option 3 is wrong, so the correct answer is just option B. Thank you.